Now, 15 to 20 billion years later, we live on a planet in a still expanding universe. We view our expanding universe with orbiting telescopes like the Hubble Space Telescope, huge radio telescopes like the Very Large Array in New Mexico, and with large optical telescopes like these on Kitt Peak in the Arizona desert. The images we see from the edge of the universe are images from 15 to 20 billion years ago. We know that the stars, galaxies, and quasars that surround us are also moving away from us because we observe a red shift in their light spectrums. This is due to the Doppler effect. When any kind of wave, either light or sound, is moving towards an observer, its frequency becomes higher. When moving away, its frequency becomes lower. The frequencies of the stars surrounding us in the universe present a spectrum of light waves that is shifted toward the red or low frequency end of the light spectrum. From this shift, we can estimate that quasars at the edges of our universe are moving away from us at about 1/2 the speed of sound. The most convincing evidence that the Big Bang took place is the microwave radiation coming to Earth from throughout the universe. This radiation is picked up by radio telescopes like these. The microwave radiation is of the same sort and from the same locations as would have been predicted by the Big Bang theory. Galaxies, like our own Milky Way, are made up of billions of stars. These groups of stars, when found in larger groups, are called galactic clusters, which in turn are found in superclusters. All of the stars that we are able to see with the unaided eye are in our own Milky Way galaxy. Telescopes like the Hubble Space Telescope and this one at the Kitt Peak Observatory have allowed astronomers to determine that there are billions of galaxies in the universe. There are three major types of galaxies known to us: spiral, irregular, and elliptical. Our own Milky Way galaxy, along with the close-by Andromeda galaxy, are typical examples of spiral galaxies. 3/4 of all known galaxies are spiral-type galaxies. From the side, spiral galaxies look like convex lenses, with a bulge of older stars in the center and more recently developed stars along the outer edges. In the Milky Way galaxy, the bulge at the center of the lens shape is about 20,000 light-years across, while the total diameter across the galaxy is roughly 120,000 light-years. The Sun, which is the center of our solar system, is about 30,000 light-years away from the center cluster. If we look at spiral galaxies head-on, we see the spirals that give them their names. Most spiral galaxies have arms that reach out from the middle of the galaxy and rotate rapidly toward the center of the galaxy. There are millions of stars in the arms of galaxies, and between the stars are great clouds of dust and gas. The gas and dust in the spiral arms often condense to form new stars. Elliptical galaxies have a smooth, round, or oval outline and tend to be made of older stars with very little gas between them. Elliptical galaxies do not rotate as fast as spiral galaxies. This slow rotation explains why elliptical galaxies do not flatten out to form spirals. The third type of galaxy is the irregular galaxy, the most famous of which is the Magellanic Cloud. Irregular galaxies are usually smaller and fainter than spiral or elliptical galaxies. Irregular galaxies also are less common than the other two types of galaxies. Irregular galaxies derive their name from the fact that their stars are spread out very unevenly. The Magellanic Cloud is thought to be in orbit around the Milky Way and is 180,000 light-years from us. Recently, astronomers have found objects at the edge of the universe called quasars, which are much larger than stars, but do not seem to be composed of stars like galaxies. Quasars emit tremendous amounts of light. For example, some known quasars are as bright as 100 trillion suns and have billions of times their mass. Quasars also emit tremendous amounts of radio wave energy. Radio telescopes at Kitt Peak and the Very Large Array near Socorro, New Mexico, were the first telescopes to identify the existence of quasars. Astronomers now theorize that quasars might be an early stage in the development of a galaxy. Scientists suspect that the core of a newly formed galaxy sucks in nearby stars and gases and releases a tremendous amount of electromagnetic energy. Our own Milky Way galaxy was perhaps once an active quasar.